Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000. So that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So this question says that Adrian, Ben and Charlie have some sweets, and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. On a scatter graph, an outlier is a point which doesn't fit the pattern. And as we can see here, all of these coordinates fit kind of a nice line going down there. So they all are showing a trend. But we've got this point here that's nowhere near that trend at all. And that's what we call an outlier. So we know that these are going up in 2s, so this will be 28. So the x-coordinate will be 28, and this will be 19. So our coordinate will be 28, 19 for our outlier. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So the first thing we need to do is work out the mean for the data in the table. So to start off doing that, we're going to work out the midpoint of each group. So we've got 80 to 85, and to find the midpoint, you add the 80 and the 85 together, then you divide by 2. So this will be 82.5, then 87.5, then 92.5, then 97.5, and then finally 100 plus 105 divided by 2 is 102.5. Next we need to find the FT, which is just the frequency times the duration of calls. Now, in this first group, we're not timesing it by 80 to 85 or anything like that. We're timesing it by the midpoint. So our midpoint effectively becomes the t. So we're going to do 15 times that, which will be 1237.5. And we're just going to keep going and multiplying each of these together. And then finally 2050. Right, next we need to add up the frequencies and add up the FTs. So we're going to have the sum of the frequencies. So I'm just adding all this column up, and that will be 80. And we have sum of the FT. And so we're going to just add this column up here. And so that would be 7,450. So what this column represents is all the numbers added up together. This column represents how many numbers we have. So to find the mean, it's all of the numbers added together, which will be 7,450, over the amount of numbers we have, which is 80. So when you do that, we get 93.125. Now this question is about the improvement that we've made, or that the manager has made, the call centre's made. So we're looking at subtracting the 93.125 away from the last week, which was 105. So we're looking for improvement. And we're going to do 105, take away the 93.125. And that's going to be 11.875. Now it does ask for 2 decimal places, so that will be 11.88. The important thing when choosing a sample is that everyone has an equal chance of being picked. So if you look at method 1, picking the first 30 students who enter the school is going to have a bias, because there might be a difference in the type of person who arrives early to school to the type of person who might arrive later. If we select a class in the school, then they're generally all going to be the same age. So if it's a year 7 class or a year 11 class, they're all going to be the same age. It might seem that it's fair that picking the first 30 students alphabetically, so A to F or whatever, again, that's not fair, because the people at the end of the register don't have an equal chance of being picked. So you need to make sure everyone in your population has an equal chance of being picked. So picking 30 students out of a hat containing all the students' names in is definitely the fairest way of picking a sample from this list. Factorising is the opposite of expanding. So instead of removing things from a bracket, we're actually putting them in a bracket. And so we're going to start off by just putting the bracket down. And we're going to think, well, what can we put on the outside? So we look at the 20x squared and the 35x. And we first of all think of the number. So we're looking for the biggest number that goes into 20 and 35. Essentially, its highest common factor. Well, that's going to be 5. And then we look at the letters. So we look at the most amount of letters we can divide out. Well, this only has an x here, so it's just going to be an x. Then what we're going to need to ask ourselves is 5x times what is 20x squared? Well, 5 times 4 is 20, and x times x is x squared. Then to get the second term in the bracket, we ask ourselves, what times 5 is 35? Well, that's going to be 7. And what times x is x? Well, we don't need an x on the end of that. 5x times 7 is 35x. And you can actually expand that, and you can use any method you want. But I'll use smiles and rainbows. And so we're going to do 5x times 4x, which is 20x squared, and 5x times 7, which is 35x. So our answer will be 5x brackets 4x plus 7. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So here we've got right angled triangle. We've got two of the lengths and an angle involved in the question. So we're going to be using trigonometry. And we're going to start by labelling the sides. So opposite the right angle, we call this the hypotenuse. Opposite the marked angle will be the opposite, and the length between the right angle and the marked angle is the adjacent. Now the adjacent doesn't have any number or letter next to it, so we're just going to cross that out because that's not going to be involved in the question. We're going to do our SOHCAHTOA triangles next, and so we've got SOHCAHTOA. Now we crossed out the A, so we're not going to be using ka or toa. This question is going to be using sine, so it's going to be sine the angle equals opposite over hypotenuse. The angle is 42, the opposite is 8.2, and the hypotenuse is x. Put in our solving lines. Now if you're ever in this situation, what you can do is you can swap the left hand side with the x at the bottom. Effectively what we're doing is it's timesing both sides by x and dividing both sides by sine 42. When you do that, you get x equals 8.2 over sine 42. Now be careful on the calculator here, because when you type in sine, it opens the set of brackets. Just be sure to close the brackets before you press the equals. So we get x equals 12.254 blah blah blah. And rounded to two decimal places, that's going to be 12.25. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%. Well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. So we're going to write out the formula again, just to give us a bit of space. And so we've got 4w over 7 plus 91. So going to first of all put our lines in, because we're asked to make w the subject. So we need to remove everything that is in our way. Well, this plus 91 is the first thing we get rid of. So what's the inverse of plus 91? Well, subtract 91. So we're going to subtract 91 from both sides. So we've got a take away 91 equals 4w over 7. Next, we've got this 4w that's trapped in this fraction. So we've got to get rid of this fraction here. So that is over 7, or divided by 7. How do we get rid of that? Well, we times both sides by 7, because divide, the opposite there, or the inverse of divide, is times. So we're going to end up with 7 times a minus 91, so it's timesing the whole thing, equals 4w. The last thing we want to do is get rid of this 4 here. Well, that's a times 4, so how do we get rid of it? Well, the opposite of times 4 is divided by 4. So we're going to divide both sides by 4. So 7 brackets a minus 91 over 4 equals w. Now, some of you might be thinking that we haven't finished the question because we've got a bracket still, but actually the bracket is absolutely fine to leave. We don't need to expand it. We can write the equation of any linear graph as y equals mx plus c. So m is the gradient and c is the y-intercept. So we've got to find what the gradient and the y-intercept are. Well, I'm going to first of all try and figure out what the gradient is, because we're actually given some clues here. We're told that the line is perpendicular to the equation given. Now I'm going to rewrite this a little bit just to make it a bit clearer what the gradient of this is. So I'm going to write this as minus 1 over 12. I'm just going to leave a bit more of a gap there. Minus 1 over 12 x plus 12. And you can see that the number before the x, the coefficient of the x, is minus 1 over 12. But we're not told that it's parallel to that, so it's not, the equation that we've got is not going to have the gradient as minus 1 over 12. We're told it's perpendicular. Now, when two things are perpendicular, to find the gradient of the other one, if we know one of them, you've got to change the sign and find the reciprocal of the fraction. So to find our gradient, we're going to change the sign, so it's negative, so our gradient is going to be positive, and we're going to flip it. We're going to find the reciprocal. Reciprocal of 1 over 12 will be 12 over 1, or just 12. So the gradient of our line is going to be 12. To find the y-intercept, we're going to use the points given to us. So we've got x equals 3 and y equals 4 for a point on our line. We're going to substitute those into the equation we've got. So it's going to be 40 equals 12 times 3 plus c. Put in our solving lines. 12 times 3 is 36. And we're going to take away that 36 both sides. So it's going to be 4 equals c, or c equals 4. So our equation will be y equals 12x plus 4. To find the distance or displacement on a velocity time graph, we're actually going to find the area underneath the graph. And to do that, we're going to split the graph into two. And we've got the trapezium on the left-hand side, and we've got this rectangle on the right-hand side. So to work out the area of the trapezium, we're going to do half a plus b times the height, and the two parallel sides are on the left and the right, so it's going to be half times this part here, which is 40, plus this point here, which is 160, and then the height is actually the width, so the height is this bit here, so it's going to be times 2. Those will cancel out, the half and the times 2, so that would be 200. And similarly, to work out the area of B, it's just length, width times length. So that's going to be 3 wide, and again 160 tall. So 3 times 160, which would be 480. And so we need to work out the total area. And we do that just by adding the two together. So 200 plus 480, which will be 680. When we add fractions or integers and fractions, we need the denominators of the fractions to be the same. And when we've got an integer, we just convert it to a fraction. And here we've got 9k, and we need to convert that to a fraction that is over k plus 9. And the way we do that is we get the 9k, and we times it by k plus 9 over k plus 9. And effectively, k plus 9 over k plus 9 is just 1. So we're doing 9k times 1. So we're keeping it the same. We're keeping it as 9k. So what we do when we times a 9k or a term by a fraction is we times the top, the numerator of the fraction. So it's going to be 9k brackets k plus 9, and all of that over k plus 9. Expanding the brackets, we get 9k squared plus 81k over k plus 9. And so what I'm going to do is just feed that back in here. And so we've got 9k squared plus 81k over k plus 9, which is just that 9k bit, plus 11 over k plus 9. And whenever we're in this situation here, we just add the numerators. So it's going to be 9k squared plus 81k plus 11, and all of that over k plus 9. And that will be our answer. So let's put that in our answer field. We're going to start by working out what outcomes will give us two different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, or the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26. And so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together, and when you add them together you get 234 over 702. Now I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. So when we have two equations that are both linear, we obviously do solving through elimination. But here we've got a kind of quadratic-y, kind of circular graph on our second one. So we're not going to be able to use the method of working downwards and eliminating the x or the y's. But here what we can do is we can solve through substitution. This first thing says that instead of y we can write 5x. So what we're going to do is just write out the second equation, but instead of y we're going to write 5x. So we've got x squared plus, and instead of y we're going to write 5x, and we're going to put it in brackets because we're going to square it, plus 10x equals 111. So we can actually create a quadratic from this situation. So we're going to just square that. So that's going to be 25x squared plus 10x equals 111. I'm going to just put our solving lines in. It's not much solving to do, because all we need to do is take away 111 from both sides to get it equal to 0, which we need to be able to solve the quadratic. So x squared plus 25x is 26x squared plus the 10x, and we're taking away 111 from both sides, so that will equal 0. So looking at the question, it says to 2 decimal places. It's a calculator question. Chances are we're going to be using the quadratic formula. So for the quadratic formula, we need to find out what a, b, and c are. A is the coefficient of the x squared, which is 26. B is the coefficient of the x, which is 10. And c is the number on its own, which is minus 111. So we're going to substitute those into the quadratic formula, which is x equals, and then we put our fraction in, and we've got minus b, and I always put them into brackets, plus minus, and you'll see why if you ever have negatives, so you can get in real problems when you have negatives. It doesn't take much longer to put them into brackets. Minus 4 times a, which is 26, times c, which is minus 111. And then all of that over 2 times a, which is 26. So we're going to do this once with a plus there. And so when we have a plus there, we got 1.882 blah blah blah. And when we do it with a minus there, we get minus 2.267 blah blah blah. But the problem is those are x values, and when we solve we've got to also find out what the y values are. Well, we actually have a really nice way of finding out the y value, because if you look at this first equation, it says that y equals 5 lots of x. So all we need to do is multiply these x values by 5. So we're going to times that first one by 5, and we get 9.414 blah blah blah, times the second solution of x by 5, and we get minus 11.337 blah blah blah. And so when we round those to 2 decimal places, which is what the question asks, we can have 1.88 and 9.41, and we have minus 2.27 and minus 11.34. So to find the shaded part of this diagram, we need to first of all work out the volume of the smaller cone, which is at the top. Then work out the volume of the larger cone, which is the whole cone shown, and then take them away from each other. So the radius for the smaller cone is 4, and the height is 5. And the radius for the larger cone is 20, and the height is the 20 plus the 5, so it would be 25. So I'm just going to label them A and B. And so why don't we work out the volume for B first? And the formula for the volume of a cone is 1/3 pi r squared h, with h being the perpendicular height. So it's 1/3 times pi times 20 squared times 25, which is going to be 10,471.975 blah blah blah. We're going to work out the volume for A, and this time it will be 1/3 times pi times the radius now is 4, and the height is 5. So that will be 83.775 blah blah blah. So to work out the shaded bit, we're just going to do the volume for B, take away the volume for A. So it's going to be 10,471.975, take away 83.775. And all those I'm going to keep in the calculator to keep the accuracy. And that gives us 10,388.199, blah blah blah. And to 2 decimal places, it's going to be 10,388.20. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.